Good morning, guys. Today I'm gonna make a video on a simulation. I'm gonna make a part, an extrusion, then make a simulation on it to see the stresses of which are acting upon the component or the part of the material, whatever you would like to call it. So yeah, first we'll just make our extrusion. I have made extrusion videos, so yeah, if you need if you need a revision on that, you can always check the recent videos I've made. They have better explanations on extrusions, but for now, the main focus is the stuff that you have to put in when you're about to make a simulation. So we'll call this mild steel. Mild steel. In general, I will have a mild steel density of 7,850, could be kgs. Yeah, it could be in kgs per cubic meter, depending on the units you want to use. But yeah, you could use that for kgs. Yeah, for kgs per cubic meter. Then the next one, you need to put your elasticity. The material should be elastic. In this case, you're talking plastic deformation. So Young's modulus, you have 210 gigapascals, and then Poisson's ratio is 0.303. You need to make a section, has to be homogeneous. It is mild steel, and you need to select your section. Then your assembly, you need to make an instance. You need to make a step, has to be static. Let's call this beam. And put in a load, make it concentrated, and we will put it on that corner. And these are directions of loads. So for that direction, it will be 0. This direction, the positive value that you're going to put is actually going to give you an upward force, but I want a downward force, so I'm going to put a negative sign right there. So I'll make this 45,000, then in that direction it's 0. So right there you have that arrow pointing downward as your downward applied force, 45,000 Newton. And then you have your anchor, or this would be this would be the part of the, it will be the section of your part of which is actually stagnant. Perhaps it's connected to a wall, perhaps it's connected to another component, maybe by welding, by bolting, like there's a lot of ways to anchor component, but this is how we do it on the simulation. And we select that anchor right there, and just like that, that's your anchor. Meaning this part is anchored, it is not moving, it's not supposed to move. So now we make a mesh. You select a part, 10 instances. I will apply that 10 local size, then finally create my mesh. And that's my mesh. And then right now I need to make the job. So that will be my job. I'll call it, it's a beam job. And then I have to submit the job. And then as it's been submitted, it's gonna run trying to compile information on what you've just entered as your input. Then now needs to show the output, so it needs to go through the whole process of gathering data and then giving it out to you. When it's done, you want to check our results. So first, check out deformation. So that is our undeformed shape, and that is our deformed shape. So that is it. It's deformed. And if you want to check out stresses, you just come right there, and you can see that part right there that we selected is the one that has more stresses on it, because it's the one that has more force on it. So yeah, that's about it. You can also do an animation on it to check, just to have fun of everything. And yeah, that's how it is. You can also make a section. So this is half of it. This is half the part. So you can see on the interior how do the stresses look, and you can even get the values of those stresses for those different mesh properties. And then what you can also do is, okay, you can also see the deformation of that. What we can also do is we can try and change the mesh. Let's try and change the mesh. So let's try and make this an 8. Let's apply that. And let's make our mesh. So right now it's a bit smaller. It's a bit smaller and a bit close to accuracy than our previous one. So we have to go back to our job, submit a new one, because we've submitted new data, we've changed something. So we need to submit again and check it out. Alright, it's done now. You can go check our results. That's the deformed shape, and those values have changed, and the stress as well has changed a bit. It has changed in such a way that it is a bit more accurate than it used to, because now we've put in a smaller mesh size, which is more accurate. And that is also interesting to see right there, that part right there, that is a stress. So you could see if you apply a stress there, that part of your component that is anchored is going to have some stresses on it. So these parts here are the ones that are prone to fail, either by fracture. Well, it will be by fracture. So depending on the material that you have, looking at mild steel, usually mild steel is more ductile than aluminium, so it might fail in a ductile manner. But then looking at the forces that you also apply as well, you might have your ductile material failing in a brittle manner. So depending on the forces you give in and also on the material type, you will see fracture there, and whether it's brittle or ductile, that will depend on your material. So yeah, that's it for this one, guys. Thanks for watching. See you next time.